Hello there. You're listening to Oyla, a science podcast for students. We tell stories that make you smarter. Don't forget to subscribe so you don't miss our latest episodes. You can discover even more about science and the world around us in our magazine, so head over to Oyla to check it out.
Science and technology don't stand in place. Scientists around the world work to ensure that the production of fresh and healthy food is simple, cost-effective, and environmentally friendly. So, in place of classic garden beds and greenhouses comes hydroponics, growing plants in nutrient solutions without soil. Hello, friends, and welcome to the Oyla podcast. The idea of growing plants without soil is not new. Back in 1699, the English naturalist John Woodward described his experiments growing peppermint in a soilless environment. The plant died in desalinated, distilled water, but it continued to grow in untreated water. Probably, Woodward reasoned, the mint extracts something from the water that is necessary for growth. Now we know that the plant needs many mineral substances for normal growth and development, including calcium, iron, potassium, magnesium, phosphorus, and sulfur. Scientists take them from the soil. Some predators, like Venus flytraps, get them from the bodies of their victims. But for this, there must be water in the soil to dissolve the mineral substances, making them accessible to the roots. Plants don't need the soil itself, they just require mineral substances from it. Woodward's experiments gave rise to much reflection, but until the beginning of the 20th century, the cultivation of plants without soil remained an area of exclusively scientific interest. In the 1930s, American biologist William F. Garrick brought hydroponics out of the laboratory and into the light. He insisted that growing plants on a large scale without soil, but instead on nutrient solutions, is not only possible, but also makes a lot of sense. His colleagues were skeptical about this idea at first, but when Garrick showed them tomato shrubs a few yards tall that were grown with an aqueous solution of mineral substances, they changed their mind. The University of California, where Garrick worked, even allocated huge areas for such experimental greenhouses. He called his revolutionary method aquaculture, but there was some confusion. The word was already in use for the breeding of aquatic organisms, fish, algae, mollusks. It was then that he introduced a new term, hydroponics, which we still use to this day, as it carries the understanding that this is the cultivation of plants using nutrient solutions and without soil. The first mention of the commercial use of hydroponics was in 1938 when Time magazine published an article about tiny Wake Island in the Pacific Ocean, where Pan American Airways planes landed for refueling. Among other things, the article said that barrels with mineralized water, in which beans, tomatoes, and other vegetables were grown, were installed on the island. This food was intended for the aircraft crew. During World War II, there were more of these kinds of farms. The military needed fresh vegetables, and it was difficult to deliver them. Today, hydroponics is widely used all over the world. For example, NASA is studying the possibility of growing vegetables on a spaceship in a closed ecological life support system. The success of such an experiment will lead to new prospects for space travel. Humankind has been growing fruit and vegetables for thousands of years. Why spend money on technological development when you can just stick a plant in the ground? Because hydroponics has a lot of advantages. It gives us the opportunity to grow food in places where traditional agriculture is impossible. In arid climates like Israel and Egypt, hydroponics has been used for several decades. Thanks to this method, it became possible to purchase locally produced food on the market rather than importing these products from other countries at a high cost. Similarly, hydroponics are needed where space is limited, even for humans. For example, in Bermuda, these systems occupy only 20% of the amount of land that would be required for crops. In regions that are cold and have few sunny days, hydroponics allows you to harvest a high yield of local vegetables and fruits. In cities with poor ecology, the cultivation of plants without soil solves several problems at once. Greenery appears, which is typically rare in densely built-up areas. And along with it, food products start to grow in homes and offices, which leads to almost unlimited access to fresh, healthy food. The deciding argument in favor of hydroponics is the high environmental friendliness of this type of agriculture. The water circulates in a closed system, it passes through purification systems, is enriched with nutrients, and again flows to the plants. This is extremely important for areas where there is little water, such as in the Middle East and parts of Africa. Besides, almost no pesticides are required. The conditions on farms are practically sterile, and hydroponics require only about 25% of the amount of fertilizer necessary for growing plants in soil. This approach saves money and contributes to the preservation of the environment. Finally, since the food is grown on site, there is no need for it to be transported again. Both the producer and nature benefit. Hydroponic farms are similar to conventional greenhouses, but instead of beds, there are special shelves, under which grooves with nutrient fluid are located. Seeds are kept in a special incubator until the first shoots appear, and only then are they sent to the hydroponic farm. Since the roots of plants are immersed directly in the nutrient solution, vital substances do not need to break through the soil layers. The root system grows minimally. Thus, all organic substances synthesized by the plant go to the construction of shoots, leaves, and fruits. Under such conditions, the plant grows extremely quickly. A salad bush on the soil bed grows in a couple of months, while in a hydroponic farm, it takes only 30 days. To obtain a large crop, it is not enough to just provide plants with nutrients. The growth of crops is affected by many factors that need to be kept under control. To do so, dozens of sensors are installed in the greenhouses. They monitor the acidity and electrical conductivity of water for irrigation, ambient temperature, humidity, brightness, and CO2 supply. Well-designed heating systems located near the plants create a uniform temperature regime around the plant and enhance gas exchange. Artificial lighting allows you to control the development of plants, to accelerate or slow down flowering, and to affect the maturation process. All you have to do is extend daylight, and the development of long-day plants will accelerate, which means that the harvest can be collected much earlier. Knowing exactly how each part of the light spectrum operates on cultivated plants, scientists and engineers have created phytolamps that emit light in the red and blue regions of the spectrum. Conditions are created to enable the maximum intensity of photosynthesis, and plants begin to grow faster. The conditions in the greenhouses are so conducive to growth that the plants grown in them are always beautiful, bright, and juicy.
You've been listening to a podcast brought to you by Oyla, a science magazine for students. Please subscribe and check out our website, Oyla, for more information.